Today we are looking at module 3. This is week 3 and we are looking at module 3. So we are right in time and on time for our lecture series. Okay, so by the end of today's lecture, you'll have almost 60% what you should know for you to be able to prepare for the exams. Okay, so yeah, congratulations. So today we are looking at utilizing data. Okay, last week we looked at an interesting module. We also did some demo, a simulation on how you can collect data from the environment and display it. And I hope you enjoyed your tutorial session and the lab session that you had to do the exercise. Yeah. So you have to continue practicing, engaging, and learning and exploring. Like I said, I want you guys to be active learners. Yeah, it's you who wants to learn more than anyone else. It's you who wants the knowledge, and you have to seek for it. The materials are there. You can learn from everywhere, anywhere. So yeah, it's up to you. And this course is an interesting course and it is applicable. Okay, so you have to take initiative to learn and understand the concepts, practice. And I'm sure compared to other modules or other lectures you've been having, this one is a little bit more structured and engaging. Okay, and it gives you time and opportunity to learn, okay, and practice. Because now imagine the way it is structured. We have lecture series, lecture sessions to explain the concepts and the theory behind IoT. You have the tutorial sessions where you have activities that you engage in every week, and you have groups that you discuss with that you can learn, and you also have lab sessions that you can do to practice and grasp the concepts. And above all, you have tutorial assistants that support you, that help you learn better. So, yeah, if you don't learn from this course, then you not blame anyone else but yourself. And also, if you don't perform well, also, you blame yourself, not anyone else. Okay, we are doing our best. So today, we focus on how IoT data moves through its life cycle, from raw signals captured by sensors to processed insights used for control, automation, and then finally decision making, like we said last week. So as an electrical engineer, you have to be curious while learning and also see where you can apply some of these concepts. So you're not only concerned with how sensors and circuits are designed, but also with how the data they generate is managed, protected, and also applied in real world systems. Okay, so you have to see how to apply some of these concepts in your own situation as an electrical engineer. Okay, so our learning objectives today, by the end of this lecture, you should be able to first explain how an IoT device collect and store data. Okay. 2, you should be able to understand data aggregation. Okay, and why it reduces redundancy. You should also be able to describe the data processing at the edge versus in the cloud. Last week we talked about edge computing, and I'm sure by this time you understand what edge computing is, and you can explain it to your friend or to yourself as well. So you will also be able to discuss security and privacy concerns in IoT. And this one is a big concern, data privacy and security. So you have to also be able to discuss that. Then explore how data is analyzed and visualized for decision making. That is also very good to understand. And you'll also be able to understand how IoT integrates with cloud computing and big data systems. And this is very good because if you have to process your data, huge data, then you need to find a way of using some of these bigger platforms like cloud computing and also big data systems. Yeah, you might not process this data using your phone or your car laptop. It might crash because the data is huge, or you might slow down the processing. Then finally, you should be able to apply this knowledge you learn from this lecture to case studies, especially in power systems, in manufacturing, and smart homes. Okay. Yeah. So let's look at the roadmap. Yeah, that is our roadmap for today. Yeah, we talked about all this. So this is what you should understand from today's session. And then how do we collect and store IoT sensor data? Okay. So to do that, first and foremost, from our sensors that are installed within the environment, we convert the physical quantities, the physical quantities that these sensors collect, for example, temperature, pressure, vibration, current, voltage. We convert all these physical quantities into what we call electrical signals. Okay, and we are electrical engineers, so you know how this happens. You convert using an analog to digital convert, for example. So you convert them, sorry, convert them into an electrical signal, and these signals are then digitized. Because remember, microcontrollers or your embedded systems, they use digital data, mostly zeros and ones. So you need also to be able to digitize some of these electrical signals into bits. Then you store this data. Remember, we said you can store the data locally or you can store the data in the cloud. So when you choose to store the data locally, then you use a memory. And last week we talked about EEPROM that you should be able to explain by the EEPROM, electrically erasable programmable read-only memory. Or you can also use SD cards, okay? And you can also use microcontrollers. So the choice is what is yours. So that is local storage, and you can now remote cloud storage. There are databases that you can use. Okay, for example, we have what you call Influx DB, we have Firebase, we have AWS, we have DynamoDB. So these are databases that you can subscribe to and be able to use, okay, to store your data remotely. Then the trade-off here, of course, not everyone can afford like cloud storage. Okay, the trade-off is that local storage is limited, but it is faster because you don't need any connectivity to the cloud. Okay, you don't need internet. You can have your local network. So it is faster, but it is limited to how much it can store. Then the cloud storage is scalable, but it needs stable connectivity. So you should be able to explain some of these concepts clearly, okay, using case examples. In case these concepts come in an exam, you should be able to explain, okay, some of these. So they might ask you to explain the difference between using a local storage or a cloud storage, and when should you use one, or why shouldn't you use the other? Now, for example, in electrical engineering, you might have, we all know smart electricity meters. Okay, we have meters everywhere. So these meters measure current, they measure voltage, okay? And then the calculation is made, and then you have what you call power consumption. And this power consumption is the one that they bill you from, okay? Remember, it is measuring current and voltage, okay? And for you, the system does the calculations and computes the consumption, how much power you consume. Now imagine you're processing this data daily. You're sending the data to the billing company daily. Like for the current and voltages, everything that is measured is sent to the company. So this will be huge data that the company might not be able to handle. So what the company does, or what you do, you store this data readings locally for the month, okay, within your meter locally. Then at the end of the month, this data is uploaded. The averages or the consumption for that month, they are uploaded into a utility company cloud database. And this database is the one that processes your billing, and then it loads it and then can send you notifications of how much you're being demanded. So this is how it is done. Okay, but not every time the current or voltage is measured at your meter that the billing company will get the data. No. If you do it that way, then you'll be doing a disservice to the utility company to have huge servers. Okay. Then data aggregation. So aggregation, what do we mean by aggregation? Yes, so that is an English word, but we all know that aggregation is combining multiple stuff. So in this case, you combine multiple raw sensor readings into summaries or averages or totals or trends. Yes, this is what I explained from the previous slide, that instead of you sending each and every current or voltage readings, you wait at the end of the month, you aggregate, and then you can have average, and you send these averages and totals and the trends, the consumption trends, okay, so that the utility company can be able to know your consumption trends and be able to advise you. Okay. Then after doing data aggregation, the purpose is to reduce data volume. Okay, I explained that one. And what you do here, when you reduce the data volume, you improve what you call network efficiency. Okay, that is very true because you're not sending huge volumes of data. So you don't need huge bandwidth. Okay, yeah. So that is an important event that you need to understand. Then edge aggregation. Remember what we mean by edge. So edge. So this happens locally. Edge is at the device, at the local device. Okay, so we have gateway that combines readings from many sensors and then sends it. So you don't allow this raw data to cross the gateway. You only allow the aggregated data at the edge to cross, okay, to the cloud. Then data, we have what we call cloud aggregation. So this happens centrally, combining data from multiple locations. Yeah, if you had a project that is located in multiple places, but you're sending the same data into the cloud to the same storage, then it should aggregate this data. When it reaches the cloud, there will be what we call cloud aggregation. It merges this data from distributed devices. Okay, and then it can analyze and store the key trends from this aggregated data. So a case example here, we can look at the manufacturing plant. For example, if you have in some manufacturing plants, we have what we call vibration sensors that monitor how the plant is operating. Okay, so if we have 50 vibration sensors that monitor motors, for example, instead of sending every vibration sample, the gateway calculates what we call the average vibration per minute. Okay? Remember, it is continuously monitoring the vibration every second. So it waits until it is a minute. This is an example, and then sends the average. Okay? Instead of every second, unless there is a malfunction. Because remember, these devices are smart. That's why we have all IoT. They are smart devices. So if there's an anomaly, it will not wait for the minute to send, but instead it will break the loop and report the anomaly. Okay, so let's move on to processing IoT data. So how do we do this one? Remember, the way we are learning this course, we are building from the previous concepts, and you should be able to understand some of these ones, so they are not hard. So processing, what we mean by processing is converting raw values into meaningful information. That is processing. Okay, you process what is sensed into meaningful information. So you have levels. Last week we looked at those 4 levels or layers. So from layer 1, which is data, then you go to layer 2, information. You process like that. So when you process the data, you get the information until you reach the decision making. So that is, so when, for example, edge processing, when you have your local microcontrollers, it can detect simple events. For example, using that PIR sensor, the passive infrared motion sensor, you can send motion detected instead of raw IR signals. Instead of infrared signals, you can only sense when there's motion, then you send that data. Or even before you even send, you first analyze, because these are smart. First analyze and see what kind of motion is this. For example, if there is motion, you're detecting people, but there is an animal passing by, a dog. Do you send that data? No. So your device should be smart enough to know that this one data doesn't need to be sent because this is not our interest. Then cloud processing. So the cloud, there is what we call heavy analytics, or what we call machine learning. And you guys, you should be able to get interested into machine learning as well. Machine learning and AI. Yeah, this is the cake for the for today and the future. You need to share on this cake and also be able to test. Okay? Yeah, don't be left behind. Learn some of these like machine learning is very, very interesting. Machine learning. So analytics, most of them analytics is done using machine learning. And then you identify pattern recognitions. Okay. Yeah. And this is the pattern recognitions are the ones you base on to perform the decision or whatever. Then you have, yeah. So all these, for example, data, we have what you call data maturity models. You should know these ones from raw data. This is a pipeline. If you have the pipeline like that, you have the raw data, then you convert it to information, then knowledge, then intelligence. We looked at all these last week. An example can be a smart traffic lights. Smart traffic lights. Sensors, for example, in a smart traffic light, sensors can count cars, the number of cars in a traffic lane, in a lane, okay? And then it can send this count to the processor. So the edge systems detect the congestion. It can detect how from the number of cars accounted, it can detect congestion within the lane. And then you can use what you call AI, the cloud AI optimization, to optimize and see which other lanes are not congested, and then they can redirect you. You can redirect you to those lanes that are less congested. If you're driving, you can first check and see which traffic has more, which lane has more congestion. Even when you have joined the lane, it can tell you that ahead you can turn and use that shortcut. That lane has no traffic. So that is what you call smart traffic cities or smart cities. That's how smart cities can work. Then moving on, privacy and security analysis. Yeah, let's look at for you to be able to analyze before you will look at privacy and security. For you to be able to analyze and visualize, you need to visualize. You need to have that dashboards that you can use to visualize some of this data. For example, in the company, you don't need to wait and people be receiving SMSs or whatever. So when you go to big companies like MTN, you find like boards, dashboards that display the traffic, the network monitoring traffic in the field. And these have IDs. So you find a huge I was in MTN, working in MTN, and I know this. So there's a huge board, and this data is being displayed and analyzed, and I'm telling you. So this is the technology. This is how you can do it. And for example, you can do what we call predictive maintenance from vibration sensor data. Yeah. And it can tell you which devices are performing badly that need care. Okay. So this is what you can do. And moving on, you can the cloud and IoT integration. So IoT devices, yeah, all these, So someone asked, how do you go to the cloud? So there are these cloud platforms that you can use, and you just need an API, application programming interface, that you can pay for, and then you're connected to some of these. And they are secure, by the way. They are secure, and you can use them. Hmm? For example, there's now Google IoT Core that you can use for your IoT applications. There's AWS IoT, there's Azure, there's a lot. Technology has advanced. Okay. And then now is the AI integration. So you don't need to do a lot of programming coding to include the intelligence within your data or within your code. You can buy some of these APIs that already embedding AI and they can analyze your data and give you insights. And of course, your thing has to be scalable enough. It has to be accessible, okay? And it has to be integrated. The integration has to be easy. For example, we have what you call interoperability, that you need to understand that some devices might not work well with other devices manufactured from different manufacturers. So there are standards for bringing these devices to work together. But if you find one standard does not support the other, then there's a huge challenge. Okay, then now we look at big data and IoT. And the way I've said it, that's how it is. Big data. That's how you should say it. If you don't say it like that, then someone will take it for granted, will be like, what are you talking about? By saying the word big. So pronounce it like big data. So it is huge data. And this data has, okay, historically has 3 V's, but now there's a fourth V. But for now, let us concentrate on the what? On the 3 V's. One is that there's high volume, generates data in high volumes. Now, high volume, for example, now for TikTok users, you guys are, most of you are on TikTok. How much data is generated on TikTok every second, for example, throughout the world, every second? Huge, right? Volume. And then velocity. You guys are engineers and scientists, you know what velocity means. This is the speed. The speed at which this data is being generated is also high, because now, like we speak, so many people are posting everywhere on these platforms. Okay. So the speed at which this data is being generated is also huge. And then finally, variety. So variety means that this data there's a lot, is not structured. For example, some people are posting images, other people are posting videos, other people are posting files, other people are posting, text. There's huge. Others are posting voice because they are talking real-time communication. So there's variety of data. Now, when you aggregate this we call it what we call big data. So when they ask you to explain big data, then in your explanation, make sure you use 3 V's. If one of the V's is missing, then you've not explained big data very well. Okay? And there are big data frameworks, okay, that you can subscribe to, because some of you might be wondering, how do I develop an application that uses big data? No, there are platforms, frameworks already developed for big data. And what you need is to design your application and then ask these guys, the frameworks, and for you to be able to connect to theirs and use. For example, there's that Hadoop, the cloud framework for big data, there's Spark. Okay, and these do what you call large scale processing, and they have huge servers that can help you. And they also have nowadays they have AI integrated within them. So it is very easy for you to make decision out of your data. Then now, like I was telling you, there's this thing called ML. So there's AI stroke ML. Okay, most of you know AI, and the way you know AI is because of the LLMs. Okay, those large language models. But that is not only AI. AI is much more than what you use, okay, to get answers from or to learn. So there's AI is a platform, is on top. Then there are other sub platforms. So ML, machine learning, is a subset of AI. Some people might confuse and say ML is bigger or is not part of AI, but ML is part of AI and it is within the AI. So it is a subset. So this one you can use for smart cities, for healthcare. For example, your wearable devices. Yeah, they are integrated with these AI capacities. Now we have Industrial Revolution 4. The Industrial Revolution. This one is integrated within these smart technologies. That's why you now find most governments talk of smart cities, smart agriculture, smart governments, smart everything. It's because of this revolution, the Industry 4.0. It has been around, but now there's Industrial 5 that is coming up. You guys, you need to be ahead of technology and know what is happening. Okay, so these ones, you can use them, for example, in your electrical systems, in smart grids. Smart grids. They use a lot of this, and there's a lot of data being generated within the smart grids. So how do you process this data and make sense out of it? So let's move on. My slide, unfortunately, is not moving. It is stuck. Oh, it was moving. Oh, we're almost there. Why is it moving? We're almost there, but we need to go back a little bit. Yes, after big data, we got use cases for IO data. So these are some of the case examples that you can provide in case they might ask in an exam that using case examples, using case examples or case studies of IoT data, explain any two of them. Okay, so you can choose from these. We have been talking about smart homes, smart grids. So in a smart grid, for example, a smart grid can detect outages and instantly balance loads across substations. Okay, this is how they do it. They can detect an outage, or if there's a transformer failure or something somewhere, they can detect quickly, and then they can divert. They can switch on the redundancy. For example, if they had redundancy within their system, they can switch on redundancy so that people are not cut off. That's what you call the smart grid, and it can do it autonomous on its own. Okay, and that is the power of IoT. By the way, if they ever ask you to explain IoT, if you want to be safe and if you don't know much, or you're this guy who doesn't want to speak a lot or to be out of phase when speaking, you can use just one word: autonomous. Okay, autonomous. In our group, we shared, okay, someone shared, but I also saw that video of an autonomous car, it is called driverless. You don't need a driver to sit on the steering and drive. The car drives itself, okay? And it has so many sensors. I think you looked at it. It is there, even it's still in our WhatsApp group. You can go and engage with it. Just learn from it. That is an example of an IoT, an electrical IoT car. You engage with it, learn. Don't just watch the video, but learn and see. And also be curious and see how some of those sensors work. Okay? It is interesting. Me, I've rewatched it several times, and every time I rewatch, there's something new that I learn. Then smart manufacturing, for example, you can predict motor failures, like if those manufacturing plants use motors, and if there's any failure of the motor, then there's breakdown. So you can use vibration analysis techniques to do that. Then the smart homes, you can have an IoT thermostats, for example, to reduce electricity bills by 20%. If it is smart enough, it will be switching off whenever there is no activity or action. Okay, and some people fear to invest in technology, especially these smart technologies, but the investment you put in, you can, in the long run, like gain it, and even it might come in twofold or threefold. Hmm? So, for example, you can leave home and then you leave your lights on. You forget to switch them off. Then you go to work and you get excited at work. You get your colleagues. You go out. You come back home at midnight to realize the entire house is lit. Like lights are all over. Oh, you'll be like, oh my God, these lights have been on since morning. Now that is the bill that you're paying. If you had a smart home, then when you lock the door, you're going out, all the thingy off. When you come back on. For example, if we have security lights at night, why should they be lighting at night? By the way, for you electrical engineers, you should be able to explain this, because some people, even me before, I didn't know that security lights, they are you know, for security purposes, to see if people, when people see light, they get scared to come closer to whatever, okay? So it's to scare people away. So what you do, the best way to use it is to let them be off, okay? Let the security lights be off. When they detect motion, when there is motion, let them switch on. If there is someone, like a thief or someone trying to sneak into your place, when the light comes on, he'll run away. He'll be like, ah, they have seen me. Vandever. You get? Because now the light will be on like this. Oh, someone will run away. So that's how a smart security light should be, but not leaving it on all the time, all the night. Remember, the more, okay, the longer it stays the whole night, the more power it consumes and the more bills that you pay at the end of the day. So guys, that's it. You can engage, for example, in agriculture. Oh, okay, you can engage all of these. Agriculture, use soil moisture monitoring. You can monitor and do irrigation. And you can also have what you call solar-powered irrigation systems that are autonomous. They monitor the soil and then irrigate on their own. You don't need to be around. And they can control the flow of water. Okay? Yeah. Yeah. This is interesting. Yeah. So I can see now at least some people have attended. Uh, People have attended at least for today, and it seems people are getting interested in IoT as well. So they are being active learners. Yeah, you need to continue learning, and I do my best because I share a lot of materials. I've shared the textbook, for example, that you can read and understand some of these concepts as well. I share all the lecture materials. I prepare tutorial activities. I prepare lab activities, and above all, I also prepare short videos that you can learn from anywhere on YouTube, on TikTok, wherever you are, you can learn and understand some of these things. Perfect. So that is it for today. You have the summary here, and if you have any question, you can ask now. Yeah, we end our session today.